Hello, fellow SOLIDWORKS YouTubers. This is Steven Darcey from GoEngineer. And today I wanted to talk to you about metal fences. So there's a lot actually going on when you look at a metal fence you don't probably think about, like the amount of press that has to actually squish the little top of that thing if it's an ornamental fence. And some of the workmanship that goes on there. So I, of course, took one of these guys and thought, hey, it'd be pretty fun to kind of model this guy up. So there's two little parts that I wanted to model up, and I modeled this guy, but I want to concentrate on this one, and this is what the video is going to be about. Now, it's a weird little depression, and what they do is they take a little press, or a big press actually, and they squish it, and when it squishes it, then that little 1x1 square tubing just kind of bellows out. And you kind of see right here, I kind of zoomed in. And sorry about the photos, are not the best quality, but hopefully you get the idea that this guy is actually pushed in. And notice when it pushes in, it actually has a little bit of a deformation here in the middle. It's a little bit weird. So what I thought I'd do is model this guy up. It's pretty easy to model up. I'm good at SolidWorks. So switch back over to modeled this guy up and didn't turn out very good. I tried to make it pretty simple. I just started out with some square boxy things. Put some little fillets on the ends, did a little cut to remove out the center point, and then I did a little boundary surface with a little sketch. And so I tried to like squeeze it out a little bit, and it turned out to be a little bit more difficult than I thought. And so I thought about this and I was like, you know what? I actually have simulation. So I wonder if I can actually just put a big piece of square metal or something, squish it together. I know what the distance is that this thing has to be. So it should be pretty easy to kind of set up. So let's go right into that model. Pretty simple. Modeled this guy up. I'm not going to go too deep into that. It's pretty easy. But I do know a couple things about simulation. If I don't have to do the whole thing, then that makes it a little bit easier. So I did model this guy with some symmetry. So I'm going to pick on the right side plane. On my surfaces ribbon, I'm going to cut with the surface. Take a look at the arrow. That's the direction that you're going to remove. So I'll say OK. And there's half my part. But then I have to go in here and squish this guy down. So let me go ahead and create a sketch. Just draw a rectangle. Make sure I get coincident on the outside edge of that. We use our little mouse gestures. Go right into dimension. And I know I'm hitting it with a 1/2-inch piece of metal and just squishing that guy down. Now what I have to do is really just break up this face. So I'm going to go to the curve feature, use split line. And all I got to do is select on all the faces that I want to split. That looks pretty good. So this is our little sneaky way to get around having to create some geometry in there. All right, so now a little bit of the setup. I am on my add-ins using SOLIDWORKS Simulation, so you have to check that guy. This is something you're not going to be able to do with the Express version of Simulation in single parts. So I've got that turned on. I'm going to go ahead and start a new study, just a static analysis. So I'll say OK. And we just go down this thing. I've got the center depression. That's good. I don't have any connections. This is just single part. I do need some fixtures though. It's going to be fixed on both these outside faces. Looks good. Then I do have symmetry. That's an advanced fixture. So I'm going to go to symmetry. And you have to select on the bottom face of this. Now it's a little bit tricky because when you first select it, it looks like SOLIDWORKS is doing the mirror command. And that's great and everything, but you don't forget to select on the other face. And the reason is because we're not really mirroring this thing or doing symmetry. What we're doing is we're just constraining the nodes on those faces in that direction. So you'll notice in this way, they can't really move, if I'm talking about normal to this face, can't move in the X and Y direction to that face. You can only move, or I'm sorry, they actually can move in the X and Y, but they're stuck. They can't move in the Z direction on that face. So make sure that you select on both faces. That can cause a little bit of an issue. So we're good there. And the last thing I need to do is push this guy down. If I don't know the amount of force that I'm putting on there, or I don't really care about the force, I just know how far down it's going, this face has to be displaced, then I can also do that with a fixture. So I'm going to go to Advanced Fixtures. I'm going to do this Use Reference Geometry, select on that face. And then the reference direction, that's going to position this translation. So I'm going to go ahead and select on plane. The right side plane is good. And then I'm going to do it normal to that. And I know that it's 0.15 inches. Now, I don't want it pulling that face up. I want to push that face down. So I'm going to reverse the direction. So the end result is actually going to push that face in that direction, 0.15 inches. So looks pretty good. I'll say OK. Next thing I need to do is just create my mesh. Right-click, Create Mesh. I'm going to drag this slider all the way to the end. And instead of doing this, I'm going to go back to my PowerPoint real quick. So we've set up the static study, and we've set up our mesh. Just drag that all the way to fine. Made a pretty good looking mesh. It's got quite a few elements and nodes, about 20,000 elements and 37,000 nodes. Okay, and then all we got to do is just run the thing. But the problem is when we run this, I get an error. The static solid fails. Now the cool thing is in 2018, you do get these little incremental changes. So even though it failed at a certain percentage, we do get a little bit of results. And you can kind of see where it does start to bellow in those little areas and stuff. But I know for a fact that this is not going to be correct. This is not true to the world. So what is the issue with this? Well, the problem is this: static versus nonlinear. So what happens is as we're starting to deform the metal, if we deform it too much, then it becomes a nonlinear analysis. So there's a couple of rules, three main rules to whether it's static or nonlinear. If the response is proportional to the applied loads, then of course it's going to be static, which means that if I add a specific amount of force, then I will get a specific amount of displacement. If I double that force, then I'll double the displacement. Everything is linear in a static analysis. Okay. Also, the material is linear elastic. So like fishing poles, rubber bands, things like that, they elasticize a little bit differently as they're pulled in force, in tension and compression. Concrete, for the most part, in compression usually has to be done nonlinear. Okay, but steels, things like that, where we're going to put a load on it and then remove the load, comes all the way back down to where it's at, then we can do that with the static analysis. And kind of that's this same thing too. If everything comes back, I'm also playing in this elastic mode. If I start to go past the yield strength of the material, then I'm also playing with a nonlinear analysis. All right, so we got those things down. We pretty much know we need to go nonlinear. So how do we do it? Well, SOLIDWORKS has done something a little bit sneaky. When I turned my add-in on, I was actually just using SOLIDWORKS Premium. I can do static analysis in SOLIDWORKS Premium. This is straight off the SOLIDWORKS website. And look, it's the most popular SOLIDWORKS that's being sold out there. It's got a lot of bells and whistles on it. Well, SOLIDWORKS is a little bit tricky. They have a standard, a professional, and premium. Kind of a small, medium, and large on the CAD side. Well, on the simulation side, they decided to do the exact same thing. So be careful on the wordage here. It's called SOLIDWORKS, but then they add in simulation standard. And then there's a simulation professional and a simulation premium. So on the simulation products themselves, we have a small, medium, and a large. Okay. Most of the stuff that's in the premium SOLIDWORKS CAD package is going to be in the simulation standard package here. They're pretty much apples to apples. You get a couple more little bells and whistles with this guy though. But what we're going to be talking about is nonlinear. Nonlinear doesn't start until you go to simulation premium. Okay, so let's take a look at that. So we're back to our model. Everything's pretty much set up correctly for the static analysis. But now what I want to do is I want to change this guy over to a nonlinear analysis. There's a couple different ways I can do it. I could right-click on static 1, just say copy the study, and then change it over to nonlinear. Okay, and there's two little options for it, whether it's a static nonlinear or dynamic. We can just use static, and that's pretty descriptive, nonlinear from the static study. And we go ahead and just say OK. Now when it does that, there's a couple other little cool things that I can do. I could split this guy up once more because everything is symmetric. And I could run this as shells. Shells are going to run and calculate a lot faster. When you're doing nonlinear analysis, these things can take a lot of time. So there's two things I could do. I could right-click on this guy, define the shells by selected faces, select all the tangent faces. That gets all the outside of these guys. It automatically detects the shell thickness there. On the offset amount, usually I'm going to zoom in here. I'm going to turn this, make sure it's on full preview. And if you flip this guy, we're fine on that. Flip this guy, top surface. Flip it, there you go. And now it's actually taking care of the right side of the offset there. So that looks pretty good. Now, the only thing I don't like about that is when you do the shells, you're still seeing this entire face of the solid model. And if I try and turn off the solid model, then it kind of all goes away. And you need to make sure that the selected surface when you created the shells are going to be the faces that you select when you create your fixtures. So kind of the issue is I've created a shells and some of my fixtures aren't going to work anymore. Okay, I'm going to do this from scratch though. We'll see how it works. And I'm going to do it a little bit different than this methodology. But I wanted to show you both of them just so you'd know. All right, let's go ahead and go back to the model view real quick. Turn our solid back on. And if I just want to steal some of those faces, then I can. I'm just going to go to Surfaces, do Offset Surface. Again, select Tangency. I want to offset them 0, so I'm just doing a copy surface. And really, I don't want these guys, because I'm going to do symmetry about the center of this as well. I could have done that in the other model as well, but this will work pretty good. All right. Now I can turn off my solid body, and you can see my shell elements there, or my surfaces. So I also want to split it one more time. This time I've got surfaces and a plane, so I need to do a trim surface. And I want to remove this outside little edge there. Say OK, and we're good to go. All right, now let's set this guy up from scratch. So we're going to do simulation. We'll do a new study. This is going to be nonlinear. I'll just call it nonlinear 2. And let's set this guy up. Now, it already has a solid body. I need to, because I just turned it off, does not mean that it's excluded from the study. So I need to go ahead and exclude it from the analysis. Then I just have a surface body. But then SOLIDWORKS doesn't know really what to do with that surface body. So I do have to edit the definition of that guy, give it a thickness. And I want to make sure again that I'm offsetting down into the part. So that looks pretty good. And we're solving that guy as thin. Go ahead and say OK. All right, everything's good with that. Again, on no connections, this isn't an assembly. But I do need to set up the fixtures. It is going to be fixed, in this case, only on this outside edge. I probably should have right-clicked and said select tangency, but that's OK. You can see me do a little bit of work there. So that guy's fixed. Now we're going to do advanced fixtures, symmetry. And we're going to be symmetric on the bottom of this. And again, I need to make sure that I select all of these edges. Again, because when we mesh this thing, we're actually just putting the constraints on the nodes themselves. So make sure you pick all 4 of those guys. Say OK. And then I also need to do symmetric about this. Now, I should have done that in the exact same symmetry. So I'll pick on that guy, right-click, select tangency. There we go. And now it looks like I've got a whole piece of square, blocky, 1 by 1 inch steel. So let's go ahead and finish out our fixtures. Now I already did one of those on the static analysis, and we can actually drag and drop. So I'm going to grab that geometry, reference geometry, and drop it in a nonlinear. Now the thing you got to remember is when we did this, we did it with the other face. So I do need to go in, edit the definition. That face is not going to be acceptable anymore. So I'm just going to clear that out of there. I need to select on this face. It's in the proper direction. Everything else is already filled out, and I can just hit OK. So 2 other things I got to do real quick. I need to go ahead and give this some material. So I'm going to go ahead and do plain carbon steel. Looks good. We'll go ahead and create our mesh. Just make sure that's all the way on fine. That's good. and I think we're good to go. Make sure you save before you run it. And we'll go ahead and say OK. And we can watch it deform as it's running now in SOLIDWORKS 2018. All right, now that the solver has finished, let's go ahead and turn off some of our symbols using the little eyeball guy there. And we do get some pretty high stresses, but I'm just worried about the shape on this thing. See if it kind of came out the way that I expected it to. And it's looking pretty good. I've got my deformation scale set 1:1. So this is kind of true to scale. And let's take a quick look at the solver messages. This kind of shows you that it did take about 2 minutes, a little over 2 minutes to completely finish the solution on this part. So a couple more fun things we could do is we can animate this thing. And this is actually going from no stress or pushing this guy in to where it's fully stressed out. Okay. And each of these times, it's actually doing the calculation on that. If we want to see any of those in between steps, then we can look at those. So you can kind of see it goes up to 1 second. So I'm going to go about halfway. And if I hit OK, then you can kind of see it's compressed it a little bit, but not fully. Now, the reason why I want to show you that is because when you go to the full step, and the whole thing is, of course, I want to model this guy up. So I want to be able to steal this shape of this edge and maybe another cross section about halfway through there, and then maybe 1 or 2 more where it's starting to not deform. And what I'm going to do is just do a loft between those two things. But once I get that, then I can right click on the results. Now we talked about the different SOLIDWORKS simulation features. Create body from deform shape is only in professional and premium. Okay. And you can put it as a configuration in this model or create a new part file. And the browse will tell you where to put it. And then you need to tell it what the plot step is. Okay. So that's if I want it all the way deformed or just at 0.1 second, I can do that and push those guys out. In this case, I want to go ahead and push out the total amount. So just to fast forward here, all I did is create a surface extrude, just created a sketch, put some little fillets on the outside edges, go ahead and trimmed out the inside. This is where the deformation starts to occur. Then I only have to do 1/4 of it. And then once I'm done, and then I can mirror and mirror. Pretty easy. Okay. In fact, I won't even need that part. So then I'm going to do a surface loft, and I stole some of the edges from that deformed body. Okay. And I really found out that I just needed these two. That pretty much got me exactly what I needed. So it looks pretty good. That surface loft came out looking pretty awesome. So then I just knit those two guys together, mirror them, and mirror them. Once I get the whole thing done, it's looking pretty good. Then we just thicken it. That creates the surface, puts it into a solid body, and then we get exactly what we want. Then we can, of course, turn off the edges, change the color to black, and it looks like an ornamental piece of steel. Looks just like the picture. All right, and we can also do the exact same thing with the end depression. So kind of same type of procedure. Started out with some surfaces, then did a surface loft, and again, used some of the little sketch features. And this one I needed 3 different little sections through there to complete it. And then I needed another surface loft going from that shape back to the original location. And I also needed to figure out exactly what the thickness offset was so that when I offset this guy, it's not going to touch. And I'll show you what I'm talking about in a bit. So then, of course, I knit those things together. It's all one surface body. We mirror it to the other side, mirror it to the bottom. You can kind of see it's hollow inside there. Then we thicken that guy. And I got to be careful of that thickness right there. So I could have probably gone a little bit thinner, but I wanted to leave a little bit of an opening there. Once I have that, this is all nice and flat. Then all I have to do is a cut. And then, of course, I can cut it on the other side or mirror it. and then I get my little swivel thing on the top. So it's looking pretty good. So hopefully you've enjoyed that. It took a little bit of time, but hopefully you got some good techniques out of there and learned a little bit about nonlinear analysis. All right, this is Steve Darcey signing off for GoEngineer. Enjoy.